Hello everybody. In this lecture, we are going to start with the linear search algorithm. So linear search algorithm we are going to use when we want to search the element from the array. Linear search is defined as a sequential search algorithm that starts with one end. Means we can start from first element also and we can start from the last element also. And will go through each element of the list until the desired element is found. Let's suppose the element is found and we can say we have found the element at that particular index. Otherwise, search will continue till the end of the dataset. Okay, in the end, if we don't find the element, we can say that element not found. So this is very simple algorithm. So if any element is found equal to the key means the element which we are searching. If we find that element, then we will say that search is successful and the index of that element is returned so that we can print that at this particular index the element is found. If no element is found equal to the key, then we will say that the search is no match found or search unsuccessful, we can say. So let's take one example. Let's suppose we have some elements in the array. These are the elements of the array. We have total 6 elements. Now, in the array, you know that the indexing will start from 0. So, A of 0 is A of 1, A of 2, A of 3, A of 4, and A of 5. So, let's suppose you want to search any element. Let's suppose I'm searching for 3. If you are searching for 3, first you will check the index number 0. On the index number 0, you have 7. So 7 is not is equal to 3. So I will increase my loop to the next index. Then I will check this element. 8 is not is equal to 3. Again, I will increment the loop and I will search the 2 index. In this way, I will continue searching the element and finally, I will find this element at the index number 4. So I can print the position of the element, that is the index number 4. Now we will see the algorithm that how we are going to work with that. So this is the name of the algorithm, linear search. In the bracket we have written array and the n basically represents the number of elements in the array and the val means value which is we are searching. Step number 1. Step number 1, we are setting the index is equal to -1. Why we are setting index is equal to -1? That we are going to see. Step number 2, I is equal to 0 we are setting because we are going to run a loop which is starting from I is equal to 0 index. Step number 3. Step number 3 is repeat step number 4 while I is less than is equal to n minus 1. Means this is a kind of for loop which we are writing in the form of language. So repeat step number 4. What is the step number 4? Step number 4 is we are checking every element of the array and which is equal to value or not. First I will check with the I is equal to 0. So array of 0 will check with the value, then array of 1. Let's suppose this matches means the element is found. Then what we will do? Then I will set the index is equal to I because we wanted to print that index. So print element found at index. Then we will go to step number 6. So what is step number 6? Step number 6 is exit because here we found the element. Let's suppose this condition is not satisfied. Then I will increase the loop. Means I is equal to I plus 1. The value of I will increase. Then I will check for the next element. So in this way, this loop will be continued until the value not found or until this condition is false. Step number 5. If index is equal to -1. So index is equal to -1 means this condition will never be satisfied. If this condition will not satisfy, then we can say that element not found. So in this case, the index value will remain -1 that we have started the algorithm. So we will print the value is not present in the array. And finally, step number 6 is X. So this is the linear search algorithm. Now we will discuss the complexity of the linear search. Let's suppose we have many elements. Let's suppose 10, 5, 4, 6. There are total n elements in the array. If you search for the element, let's suppose you are searching for any element. Let's suppose you are searching for 10. Now 10, you can see we are finding at the first position. If you are finding the element at the first position, then we need not run the loop till the last. We can stop the loop. We will say that element found at the index number 0. So this is the best case because we are not running the loop. We are not running the loop till n times. That's why in the best case, the time complexity of this will be theta of 1. Even if you find this 6, 4 or 5 at the constant time, then also the algorithm's complexity will remain constant, means theta of 1. Now we will discuss average case or worst case. So I will discuss worst case first. Let's suppose I am running the loop. Okay, in the loop, this loop will run from index number 0 to index number n minus 1. So total n times this loop will run. So worst case could be the when we searching the element, then I will find the element at the last position. Okay, means we have to run the complete loop. We have to search all the elements. Then we are finding the element. Or sometime we don't find the element. Then also we can say our loop will run for n times. That's why in the worst case, the complexity of this algorithm will become theta of n. Now, average case. Average case, most cases you will say it is n by 2. But in the complexity class, already we have studied that n by 2 is equivalent to n only. Why? Because the value of n is very, very big. If let's suppose the value of n is very, very big, means, for instance, let's consider it's infinity. So if you divide infinity by 2 also, it doesn't matter, it will come infinity only. That's why the value of 2 is not matter here. Okay, that's why the average case complexity will also remain theta of n. So this is all about the linear search algorithm. In our next video, we are going to study about the binary search algorithm.